Hello. Wow. A good full room after lunch. It makes my job even harder to make sure that all of you are attentive enough and I'm able to communicate my stuff to you. So I'll probably be more interactive rather than just me speaking and you guys taking it. So that'll also help me understand if I'm able to communicate it properly or not. Um, Before we get into what the topic of the day, I think I would love to understand the audience here so that I talk sense for you and not just what I've prepared for it. So, software engineers on the house. Wow, a good of them. So great. You'll get. I'll make sure that you'll get some good technical stuff out here after the presentation. You'll be able to do something out of it. That would be my expectations. Anyone in leadership, engineering managers like me, the boring stuff manager. Okay. Okay, got it. Product managers, TPMs, trying to sell things internally, externally to your customers, customer success managers. Awesome, cool. So let's probably begin. Quick introduction. My name is Vaibhav. I am from Bangalore, India. I'm the engineering manager for a good platform team because all the work that I'm trying to show over here, it's their hard work, and I'm just got the honor to present it over here. So the topic is the invisible backbone, AI native observability for modern platforms. Yeah, that's me. I'm not sure whether I've used the right picture or not, but yeah. Spends a decade working in platform, SRE, work at startups, fan groups, international organizations and stuff like that. Uh, I love playing table tennis. It's a stress buster. Whenever a long meeting goes off, a table tennis knock definitely cools that thing down. Love playing badminton and traveling. Traveled all the way from Bangalore to Japan just for this presentation. Going to the agenda, we'll go with the three-step stuff. We'll talk about the problem. What are we trying to solve? Or what did we solve at Mercari as an engineering organization? The approach to it, obviously, as there are a lot of software engineers out here, there are multiple approaches to the same problem coming for the solution. And then we'll actually talk about the solution that the team implemented out here at Mercari. Let's talk about the problem. A lot of text. Let's probably know the audience. How many times it has happened that you have developed your entire application and then now you are ready to deploy and then there's a huge list of checks that you need to make sure that it's completed before you are ready to deploy to production? Okay. And how many of you are creating dashboards so that you make sure that how many requests are coming, what is the latency, and kind of get annoyed that, yes, and just before deploying, I need to know all those stuffs. Awesome. So now this talk is definitely for you. The same problem happened at Mercari with us, where whenever any new product was launched or was about to launch, there was a huge list of things and had a lot of things related to observability. Because we just did not wanted to run applications, we wanted to run them reliably for our customers so that you can enjoy shopping. Now, there were multiple checkpoints. There was no set format. The different tools, different teams use different tools, different mechanisms to deploy, to create dashboards, monitors, SLOs, so on and so forth. It was managed by a code. Okay, how many of you have managed dashboards via code? Okay. Do you like it or not? How many of you don't like it? Do you find it intuitive? You create dashboards manually first and then copy paste to the code somehow? Yeah, that is the exact feeling, right? So we used to manage things by code. Now what developers used to do is they used to go create things manually and then somehow try to figure it out how do you roll it back to your code, which was a problem. Complexity, it was a lot of learning curve. For devs, the main job is to create business logics and not figure out on which is the right CPU metric that I should plot on my dashboard to figure it out. Uh, the query building was another thing, whether I should average it out or whether we should max it out or min, what would be the level of aggregations. How many of you have faced that as an issue? Like you need to figure out what is the right query to figure to plot on a dashboard. Great. So all of us are kind of related to what the problem statement is. Comes to management, you need to regular updates. Today your architecture is something else. Tomorrow you go ahead and use, instead of Cloud SQL, now you're using Spanner, and you forgot to update your dashboard. And now some surprise happened, an incident happened, and we're like, hey, I don't have monitoring for that. So same things on that part. Second is fragmented visibility. It was limited visibility to different teams. So suppose, for example, an incident happened. If my team got an learning to it, I would update my dashboard. But did that benefit any other team that could have also benefit from the same things? Obviously, there are incident management processes. There are 5 whys. You can learn from them. You can adapt to them. But it's all cumbersome because you are expecting all your thousands of engineers in your organization to kind of follow all those documents out there. Next is learning is scope to that service, the same things. And low on call. How many of you have got on calls in your systems? 2 a.m. calls, you know, you just moved to a team, you got a pager duty call, 2 a.m. You go and look at thousands of dashboards out there, you're trying to figure out where did it break and how did it break, you have no idea about it. Uh, did you relate to this problem? Exactly. So thanks for relating to the problems. No, that was low on confidence. Now let's see what did we thought about approaching to that. We wanted observability to be an enabler, not a blocker. So how do we make sure that we as platform provide the best observability to our system so that people can go and do what they are used to of building good business application logics? So that's where we went off out of the box. So the idea was that the moment you deploy things on our platform, it is our responsibility to see what you have done, what all cloud services are you using, what all Kubernetes services are you using, whatever you are using for your systems, and it should be automatically created for you without doing anything. No configuration, no code hassles, nothing, just out of the box, pure observability. Now that did not even help for production workloads, but also from the developer side of it. Like you want to experiment, you are creating a new service. Now at that time, what do you want to know is that does making a change on my connection pool have any impact on my Spanner utilization or not? So you do not want to make the same dashboards again and again. Holistic defaults, no base configuration, no additional code. Standard yet personalized. This is one thing that often a lot of people face with standardization is that you make a standard for the entire organization. While in theory it works, but in practical, every service might be different. Some services might use Spanner, some services might use Cloud SQL, some services might use Kubernetes, some services might want to deploy it on Cloud Run. Some services would use GCP, some would use AWS, some would use Azure, right? So could be possible that there are multiple flavors of services out there in your organizations. So how do we wanted to ensure that if you're creating standards, it should not be you throw everything on a dashboard, some plots, some does not plot, and now the teams figure out that whether it plots or not. And a new person comes in and says, hey, there's no data. Yes, you are not using this. So it should not happen. That's why we wanted to make sure that it's standard, but yet personalized for your application, for your systems, only gives you what you need for your specifics. Third is adaptability. The problem that we discussed about using something else, architecture changes, forgot to update, forgot to add monitors. That's where we want to pitch in. That you do change your architecture. The moment you change your architecture, we get to it, and we automatically update the dashboards and monitors. Now that does not mean I have a 24/7 team waiting over there just checking on logs and stuff and updating it manually. Let the system do it. Jumping to the solution. Quick check. Do we relate to the problem? Yes, no? Okay. Like the approach, didn't like the approach, meh. Okay. Now let's see how it works. The phase one is detection. How do we detect it, right? How do we know that your architecture is changing? How do we know that what your application is using or what specific tools your systems are using? That's where we talk about detection. And one good thing about what made our life easier was that we follow standard processes on how do you want to deploy things. So for example, if you're deploying any Terraform, any cloud resources, it has to go via Terraform. So for example, if you're using Cloud SQL, Spanner, AWS, Azure, anything, you have your own states, your own repositories. Within your directories, you make a Terraform commit, apply, and all that stuff. So you do things as usual, make your changes, and be done with it. And that's where we come in. Now, the moment Terraform applies, before I get into technicals, how many of you have used Terraform in your systems? Okay, so one thing about Terraform is whenever apply happens, it updates its state file. And that usually, as a best practice, is in a remote backend. We use GCS for it, the cloud storage. The moment any updates happen on a state file on Terraform apply, that means that you have made changes to your system and we should adapt to it on our dashboards. That's where the next thing comes in is how the moment a file create or update operation happens, we get a webhook call and put a message on a pops up. Why pops up? Because we want to make sure that we do not miss any notifications. It's a async process. It's not needed that you have to do it the moment to it, because we have SLOs of like 20 minutes. The moment you create your service, it should be updated. So pops up gives a great reliability on that aspect of it. From pops up, we trigger a Cloud Run function. Now, similarly, on the other side of Kubernetes, we leverage Kubernetes events. So the idea remains same, that whenever you make any changes, we have to get a webhook of the changes that you have made. And then based on that, we trigger a Cloud Run function, and Datadog helps us a lot over there as well. Second step, now we have detected this is what you have changed. Now how do we update things off? So that's where this controller of ours helps. We read the PubSub message. Now the PubSub message contains the state file. So for an ideation, so whenever a file update happens on the cloud storage, the message that generates on PubSub is the file name, and when it is changed, who changed it and stuff. So using the file location, we download the state file, we analyze the state file. It's a custom analyzer that we have written to analyze the state file based on what all cloud resources that you have used. Based on that, we generate a metadata service. Now, from all that state file, we fetch your metadata, which service you are, what is the owners, how many cloud services are using, what you're using, and then we have internal system. We make a lot of API calls to get relevant other metadata information that we want for generating those dashboards. After that is done, a Golang code is generated. Now, this is where Golang helps us a lot, because of its capability of high-level languages. We can do test cases, we can do customizations based on which modules to enable, which modules to disable. We can do versioning, we can do a lot of stuff based on Golang. Now, once we do it with Golang, it automatically triggers things with Pulumi. Hands raised, how many of you have heard Pulumi? Heard of Pulumi? Okay, cool. So just for reference, who have not heard of it or not used it, Pulumi is similar to Terraform. It also applies its infrastructure as code. But one advantage to that is that instead of using HCL as its language, it can work on any high-level language, whether it be Golang, whether it be Python, whether it be Java, so on and so forth, or TypeScript. So that gives an added advantage, because now you're not only forced of using HCL, and plus it makes our developer friends happy because they understand Golang better than they used to do with HCL. And then obviously conditionals, loopings, all those constructs are much better in a high-level language than in HCL. Once Pulumi detects that, okay, changes are there, it goes ahead and creates things on our observability platform, which is Datadog. So far, so good? Okay. Enough of talking. Let's see what we have built. So this is how our standard dashboard looks like. On the top, you get that you do not make any changes, otherwise it will be overridden. And then you have different sections to it. You have overview, which gives you your metadata information, who is on call, who is, what is your request, and so on. Or the availability metrics, which is what is your current SLOs, how many monitors that you have, how many are in triggered state, and so on and so forth. Then you have the request pattern. Now, this is one interesting part because now Datadog helps us a lot over there as well, because you get a lot of good metrics out of Datadog out of the box. So we leverage how many requests you have, what is the latencies, what is P95, P99 latencies for your systems, how it is performing, what is your overall graph. Yeah, and then we get some things on SLOs, how many SLOs we have, what are the SLO details, and then you might be seeing some blocks of PubSub topic, PubSub subscription. Now these are adaptable to your systems. So if you're using PubSub, then it will show you. Otherwise, it will not show for your service. If you're using subscription, if you're using Google's cloud storage, then you'll do it. We also made sure one thing is, one of the important things is that one feedback that we got that some of the dashboards has very limited information on PubSub, or some users reported that it is too much information on PubSub. Right now, that is where the personas come into picture. Right, for an intern to grasp information, or for someone who is only looking for high-level information, it's good to have a couple of high-level things. That okay, what is your oldest message size? You just day size. You just put it over there. That person might not be interested on things. But if you're an architect who wants to drill down into what was the pattern, how it happened, what all other things, right, it becomes difficult. Now, one potential solution is you put everything over here and be done with it, but that does not solve our purpose for the other users. So what we did is we gave the top level metrics, and then with every dashboard, if you see on the left side of it, there's a reference to a high level to a low level dashboard. So that means this is the top level information. If you're interested in more, just click on this, and then you'll be directed to a very dedicated page for that specific metrics, and even you can drill down further. So that way we identified and we solved the things for personas. Yeah, and the other last thing was again about how many, yeah, and the last thing was about how do you make sure that these gets adapted based on the systems. So for example, in this service that we are talking about, uses PubSub, uses cloud storage, uses service mesh on a Kubernetes cluster, and uses Cloud SQL. But it will change based on your service. Next thing, dashboards were a pretty easy things, because even if I create them, hundreds of them, they don't give a lot of hassle. Monitors is a bit aside. Like for example, someone would want to page at 2 o'clock in the night for an alert of CPU. Someone might not. Someone would like, why are you spoiling my sleep? So this is where we had to adapt based on how we had modified on a base to service thing. So that's where we went with holistic defaults, but also we went ahead with giving users capability to configure only the thresholds of part of it. So like for example, if they want to alert on 50%, 80%, 90%, and so on and so forth. And one thing that we learned in the past is that users do not want to have 10 different files at 10 different places to understand and configure observability over here, monitors over here, spanner over here, XYZ. So we leveraged something called as labels in cloud services or tags, and something called as annotations on Kubernetes. So there was a set pattern on how do we want to do it. So for example, Datadog underscore monitor, the name of the monitor and the threshold type. So if you put this tag with in your service itself as a, suppose for example on your Cloud SQL instance, or on a cloud storage bucket, or anything of that sort, we fetch that information and we put that as a threshold automatically on the monitors that we create out of the box. Yeah, and this is how, for example, a resource looks like. It's a SQL database. Now, in the SQL database, we have given that for this service, on CPU utilization at 80%, you give a warning alert, and 90% you do a critical alert. Do you want to page or not? So for example, on the Slack channel, they want to send things on alerts-spanner channel. And on PagerDuty, they want to get a PagerDuty call if something goes wrong. And this was the PagerDuty notification group for them. Well, we are sitting in 2025. I don't think so any talk can go without talking about AI. Just knowing the buzz around things, how many of you have leveraged AI in some form of the other in your day-to-day life? Wow, great number of people. So yeah, we also went ahead with cherry on the top with AI. One thing about AI is, and the research proves it, that if you give it a lot of context, it hallucinates. So for example, if an alert triggers, and if we say that, go and figure out why that alert triggered without giving any other data, then it might hallucinate. It might even say that generate something out of the box that, okay, your CPU is there while the CPU metric does not even exist. So one thing is that we have got is the moment we give the right level of context to AI, it performs better. And that number is 87%, drop down in hallucinations, and the accuracy has gone up by 54% as per the research. Second is standardization. Consistency and relevance is the key. So now, because we have the standard dashboards across the board and the standard monitors, we have central playbook systems. So the idea, the services, the AI agent can go ahead and look at if any alert triggers, look at all the relevant data on those specific dashboards and not generate any metric of its own or try to leverage any logs of its own. Go to the exact playbooks that we want, go to the exact systems that we want, and go and filter things off. Prompt, we can do better prompts for central runbooks, and that's where AI is the cherry on cake. Just a disclaimer, this is what the team is right now testing and going ahead with things. It's right now working at a beta phase within Mercari, where a lot of our applications, our pre-testers are using it internally. We leverage a lot of MCP gateways, MCP servers. We talk about open source softwares like HomesGPT and CubeGPT and stuff like that. So this is where we look the future is, and yeah. Last thing, it's always the team. So it wouldn't have been possible without the good team members that I am lucky enough to have. Kudos to the members over in the team who did a job on that. Thank you. And yeah, this is my LinkedIn QR in case you want to connect further, know anything about it. Love to talk about Kubernetes, platform, AI, anything relevant to it. Start talking about connecting about management as well. So yeah, this is what, and thanks a lot for your time and patience for listening to me. I hope it's helpful. Thank you.
Vaibhav さん、ありがとうございました。